Section 6.5, the indefinite integral and the method of substitution. Students will find indefinite integrals, use properties of indefinite integrals, and find definite and indefinite integrals using substitution. So if we start at the top, this is just a review. What is the antiderivative, or what's the integral of x squared dx? You know that you add 1 to the exponent. This doesn't have boundaries on it, so we have plus c, an indefinite integral. So I know we've already discussed it, but we'll put the formal definition to it. An expression, the integral sign f of x dx, called the indefinite integral of f, is defined as integral lowercase f of x dx is equal to capital F of x dx plus c, where f is any function for which the derivative of capital F is equal to the lowercase, and c is called the constant of integration. So these should all be reviewed for us at this point, with the exception of maybe f, but we can chat about that when we get there. So go ahead and try these. You can pause the video and then come back and check your answers real quick if you want to. I don't know what the best way is to do that. Or you can listen to me talk about them at the same time. For letter A, the antiderivative would be x to the 5th over 5 plus c. That's all there is to it. Letter B, I would rewrite that with a 1/2 exponent. This would be x to the 3/2 divided by 3/2 plus c. Fix up that coefficient. There we go. For letter C, I would actually pull this apart. I would say sine of x over cosine of x times 1 over cosine. Would I expect you to know that right off the bat? Probably not. I've just done this problem before. So sine over cosine I know is tangent. 1 over cosine I know is secant. And then when I think of my golden ticket, you know, what's the antiderivative of tangent secant? Well, it's secant of x plus c. For letter D, we will do each one of these individually. So this would be 2x, this would be the 4/3, divide by 4/3. 5x to the -1. I know it's the same thing as 5 over x. That's going to be natural log. 5 natural log of x plus c. When I clean up this first piece, the 3 will come to the top. 2 over 4 reduces to 1/2, x to the 4/3, plus 5 natural log of x plus c. For number 12, I know we're in that natural log kind of frame of mind, but this one's not natural log for either one of these. You need to pull them both to the numerator, and then they have negative exponents. So this would be 12x to the -4 divided by -4 plus x to the positive 1/2 divided by 1/2 plus c. If I clean up these coefficients and positive exponents, I've got -3 over x to the 4th plus 2 square root of x plus c. Now, letter F is kind of funny. I'm going to change colors here just to remind us that it's a little funny. I can't do anything with this right now the way that it's written. Oh, I know what they want us to do. This one's silly. I've never seen this on the AP exam, but I suppose somewhere it exists. So they're almost the same in the numerator and denominator, but not quite. So what we can do is break the 6 apart into a 1 plus 5. And in the bottom, we have an x squared plus 1. So what we're going to do is group this together so that this is 1, and then this is another. I don't love this problem. So I've got x squared plus 1 over x squared plus 1 plus 5 over x squared plus 1. If I simplify the first piece, this is just 1. The second piece stays the same. Now for antiderivatives, the antiderivative of 1 would be x plus 5. The x squared plus 1 in the denominator is going to be inverse tangent of x plus c. Kind of icky. I won't put that on the test. I haven't seen it in any of the released AP problems. It doesn't mean it's not an option, but I just haven't seen it. So that takes us to the use substitution method. And this method, we will use substitution to transform the integral into a form that can be integrated. We're going to take something that's more complicated and hopefully make it a little bit easier. So This is kind of the mathy definition of what's going on. If you recall learning the chain rule, we had to find u and du. We're going to do the same thing here, but now we just have to integrate. So I'm going to start with the u. So for letter A, I'm going to say that u is equal to 3x plus 2. Then we have to find the derivative of that. So that's du dx, which would be 3. Now, we want to separate that differential, that d over dx, and so we'll say that du is equal to 3 dx. All right. And then we're going to do one more thing. We ultimately need to get dx by itself. So we've got du over 3 is equal to dx. Mrs. Charnley, you just did all this crazy stuff. What is going on here? Well, we need the u, and we need the dx. So we're going to take this sign problem. So this is sine. Instead of 3x plus 2, we write u. Instead of dx, we will write du over 3. So we're taking things out of x world and moving them into u world. Now, this over 3 is a constant inside the problem. I don't need it for anything, so I'm going to pull that to the front. 3 is still in the denominator, so it's 1/3. Sine of u du. And then you ask yourself, okay, what's the antiderivative of sine? I know it has to do with cosine, so I have to remind myself, is it positive cosine or negative cosine? Be negative cosine of u plus c. So we've gotten into u world, we've done the math in u world, now we need to get our answer back into x world. So we are going to replace u with what we said it was at the beginning. So negative 1/3 cosine of 3x plus 2 plus c. Excellent. All right. Mrs. Charnley, how do we know when we have to use substitution? It takes practice, just like it took practice to figure out when we need the chain rule. It's the same idea here. You're putting the chain rule back together. So if you see pieces that would work for that, it's most likely use substitution. Look inside the radical, look inside the parentheses, look inside the exponent, look in the denominator. Those are all good places to start. None of them are foolproof methods, but those are all good places to start. And sometimes you have to trial and error. You might have to erase it, and that's okay. You just go again. So with letter B, I'm looking inside the radical. I'm going to say that u is x squared plus 1. Du is the derivative of that, 2x dx. So I'm already going to split those two apart like I did over here on the left. I know that we can do that. I'm going to solve for dx, so du over 2x is equal to dx. So I have the two things I need, I have my u and my dx. So let's start replacing. Now this x in the front, just leave it there for a minute. Inside of the radical, instead of x squared plus 1, I have u. And instead of the dx on the end, I have du over 2x. Here's what's going to happen. The x that's in the front and the x that's in the denominator will cancel out because x divided by x is 1. So this is really, I'm also going to pull that 1/2 to the front, square root of u du. So 1/2 u to the 1/2 du, still the integral. Now the antiderivative, we add 1 to the exponent and divide. So 1/2 u to the 3/2 divided by 3/2 plus c. If I deal with that coefficient in the front, I have 1/2 times 2/3. At the same step here, I'm going to replace u. I'm going to get it back into x world. X squared plus 1 to the 3/2 plus c. In the front, I have more 2's that are going to cancel out. So my final answer is 1/3 x squared plus 1 to the 3/2 plus c. There you go. There's your answer. Letter C. You want to think to yourself, okay, what possibly could be u? I see denominator, I see an exponent. We're going to go with that square root of x. the derivative of the square root of x, remember this is really x to the 1/2, is 1/2 x to the negative 1/2 dx. So du, watch this, is 1/2 square root of x. Now, again, we're going to solve for dx. So I'm going to say 2 square root of x du is equal to dx. So I have the u definition that I need. I have the dx definition that I need. When I start to replace the original problem and get it into u world, this is e to the u over the square root of x. That's okay, just leave it there. It should work out. And in place of dx, I'm going to have 2 root x du. Go through and see if there's anything that divides into be a 1. So square root of x and square root of x. This would be 2 integral e to the u du. What's the antiderivative of e to the u? It's e to the u. This gets a plus c, but I'm still in u world. I have to get back to x world. 2e square root of x plus c. Excellent. Now, in letter D, I have e to the x on the top and the bottom. You want to kind of get as much into that e to the x that you possibly can. So I'm going to define u to be the entire denominator, e to the x plus 4. Because when I look ahead, I know the derivative of e to the x plus 4 is e to the x dx. And if I solve for dx, that du over e to the x equals dx. So I know that this is a good thing. I see a plain e to the x in the numerator, and I'm pretty sure that's going to work out. I know it's going to work out, but this becomes e to the x in the numerator. The denominator is now u. dx on the end is du over e to the x. Guess what? What happens with e to the x? E to the x divided by e to the x is 1. This is 1 over u du. What's the antiderivative of 1 over u du? ln of u plus c. Replace that u with e to the x plus 4. And you have your answer. Nice job. All right, example 3. We're going to prove this once, and then you're allowed to put on your golden ticket and just memorize it. You don't have to do anything else with it. So, tangent. I know that tangent can be written as sine over cosine. So this is the sine of x over the cosine of x dx. When I look at this problem, I know that the derivative of cosine is sine. I know the derivative of sine is cosine, depending on the negative signs. So this one could go either way. But I know that u is equal to cosine of x because du must be in the numerator. That is a hard rule. There's no exception to that rule. Du must be in the numerator. Now, you can have like a 1 over x dx and all of that together is du, but that cosine can't be du. So if I know that cosine is u instead, the derivative of cosine is negative sine dx. So I have sine of x dx over cosine of x, but that's going to be u. I forgot to solve for dx. Let's do that here. So dx is du over negative sine. So this is du over negative sine of x. Sine of x divided by sine of x I know is 1. I'm going to bring the negative to the front. 1 over u du. The antiderivative of that is going to be negative ln, absolute value of u, plus c. Negative ln cosine of x plus c. There we go. So you can actually add that. There's a spot for that on your golden ticket on the antiderivative side. You can add that on there and just memorize it from here on out. All right. These 4 examples have kind of unique situations when it comes to use substitution. Letter A is pretty straightforward. Letter B is a little bit unique. C and D rely on those inverse trig functions. So I'm going to start with A. We'll kind of keep it straightforward here to start. So I'm going to say that u is the denominator. It's that 4x cubed minus 1. Let me zoom in here. So the derivative of that is 12x squared dx. And if I solve for dx, it's du over 12x squared is equal to dx. So if I come over here to my original problem, Leave the numerator the same, 5x squared. 4x cubed minus 1, that's really u. And dx on the end, I'm going to replace with du over 12x squared. And if I look around, there's a couple things going on. X squared divided by x squared is 1, and the 5 over 12 isn't necessary for the integration, so I'm going to bring that to the front. There's a 5 in the numerator, 12 in the denominator, 1 over u du. We have 1 over u du again. What is the antiderivative of that? We know it's natural log of u plus c. And then we want to replace u. So what goes in place of the u? 4x cubed minus 1, with a plus c on the end. So there's our answer. Good. Your answer always needs to be in x world. Now, for the second one, you're still going to figure out what u is. And this one's a little bit clumsier, but it will be okay. U is inside of that radical. So I'm going to say that u is equal to 4 plus x. The derivative of that is going to be 1 dx. All right, cool. So over here, x is in the front. We're going to turn the inside of that radical into u world. And now we know that dx is equal to du. So we have 1 foot in x world, we have 1 foot in u world. We have to get all the way into u world. And the problem that we have at this exact moment is this x. How do I get rid of that x? I don't have anything exactly the same over here on the right-hand side. We have something close. So you're going to take your u equation and solve for x. So u minus 4 is equal to x. Okay, so now I can take this x in the front, replace it with a u minus 4. Everything else stays the same. Great, we're fully in u world. But good grief, it looks just as complicated as it was in the beginning. But the good news is it's not. I have this quantity u minus 4. The square root of u is really u to the 1/2, so we can distribute. So this would become u to the 3/2 minus 4u to the 1/2 du. We can find the antiderivative of each piece. This is u to the 5/2 divided by 5/2 minus 4u to the 3/2 divided by 3/2 plus c. I'm going to clean up those coefficients. So 2/5 u to the 5/2 minus 8/3 u to the 3/2 plus c. I'm still in u world. I need my answer in x world, so I'm going to replace those u's with x's. And we said that u is equal to 4 plus x. So 2/5 4 plus x to the 5/2 minus 8/3 4 plus x to the 3/2 plus c. It's messy, but that's the answer. Good job. All right. Now, letter C. This one kind of jumps right in. It looks kind of, sort of, almost like inverse sine. And if I look at the derivative of inverse sine, I know that it's 1 over square root of 1 minus x squared. The problem is we don't have a 1, we have a 4. So we have to ask ourselves, okay, how do I take this 4 and make it a 1? Well, we can divide. This feels a little weird. Or multiply everything by 1/4. Maybe that makes sense. So if I multiply the bottom by a 1/4, I'm also going to multiply the top by a 1/4. So I have 1/4 dx. And I should say it's not really a 1/4, is it? I need it to get inside that radical, so therefore it has to have a radical itself. So I'll put a radical over both of these. So I've got 1 minus x squared over 4. Everything inside the radical. So kind of convince yourself that you're okay with that. You might not be, but that's what happens there. Now, instead of starting with u, I'm going to look in this spot here, and that's an x squared. So for me, I'm going to start with u squared. U squared is x squared over 4. Then I need u, which is the derivative, not the derivative, the square root of both of those. So that's x over 2. And then du is the derivative of that, would be 1/2. That's the coefficient in the front. The derivative of x is 1 follow up with dx. If I solve this for dx, this is 2 du. Have I lost you yet? There's a lot happening here. So my 1/4 in the numerator that's in the square root, I'll bring that to the front. It's really 1/2, but we'll simplify that in the next step. Dx, I know, is the same thing as 2 du. The denominator, 1 is still 1. And x squared over 4 is now going to be u squared. Okay, let's give myself a little bit more space here. So 1/2 in the front. The 2 in the numerator doesn't really need to be there. I'm going to pull that to the front. Du over the square root of 1 minus u squared. Guess what? 2 times 1/2 in the front is 1. The inside of this integral is inverse sine of u plus c. We have to get it out of u world and back into x world. Inverse sine. Now, be careful. You want to grab u and not u squared. So this is your u down here. So x over 2 plus c. Yikes. I know that has a lot of steps. I did not stress that this school year. If this is a video for a different school year, it might be on your test, but for the current school year, it is not. Okay. Letter D. The first thing I would do is try to make the entire bottom u and say 9 plus 4x squared is u. The derivative of that would be 8x. The problem is I don't have another x that I know is going to simplify and cancel that out. So we need to think inverse trig again. Now, what's this one close to? I'm going to go with inverse tangent. Looks something like that. Or maybe it's x squared plus 1 on our golden ticket, but it's addition, so it doesn't matter. So when I'm looking at this problem, hey, we're close, but it's that 1 that doesn't match. So I need to make this 9 a 1. And the way that I'm going to do that is to multiply top and bottom by 1/9. So 1/9 dx, 1 plus 4 over 9 x squared. So again, I know it's close to that inverse tangent. We'll start with u squared. Inverse trig generally starts with u squared. The square root of that is 2 over 3x. The derivative is 2/3 dx. So if I solve this for dx, 3 over 2 du is equal to dx. So let's start replacing. 1/9. We'll leave it inside for now. Dx is 3 over 2 du. 1 plus u squared. So the denominator's looking good. I got 1 plus u squared. That numerator, that 1/9 times 3 over 2, would all become a 1 over 6. I'm going to bring that in the very, very front. 1 over 1 plus u squared du. I know that this is inverse tangent of u plus c. 1/6 inverse tangent of u. Again, remember, grab u, not u squared. It's going to be 2/3 x plus c. Kind of crazy substitution. All right, definite integrals with substitution. So on letter A, you would probably just do this in the normal way, and that would be totally fine. I looked in the textbook to see, what made this one different. And because it's an even function, it's symmetric around the y-axis. So the textbook actually went from 0 to 2. It'll save you a little math because putting 0 into the problem works, but it's one more thing to memorize and one more thing to know, and we already have a ton of that stuff. So in all honesty, I would just do it the regular way. I would say x to the 5th over 5 minus x cubed over 3 plus 3x between -2 and 0. Nope, I said 0, between -2 and +2. So I put those values in, run all the way through and get the final answer. I don't have a calculator in front of me to figure out exactly what that is, but I'm sure that you can do it and have no issues with that. But letter B, this is the newer one. This is the one we should really be paying attention to. Start inside the radical. U is 4 minus x squared. du is the derivative of that is negative 2x dx. Solve for dx. I'm going to do negative 1 over 2x du is equal to dx. I'm going to start substituting. So x square root of u dx I know is a negative 1 over 2x du. I know that x divided by x is 1. I'm going to bring this negative 1/2 to the front. Square root of u du. Now, I very purposely left something blank, and that's the boundaries. At this particular step, I'm both in x's and u's, and so I didn't want to put anything there. But down here on the bottom row at the moment, that's all in terms of u. So, as a reminder, these are x values. We're in x world, those are x values. If I'm in u world, I need those to be u values. So how do I make them be u values? You're going to come over here to your u equation. I see the bottom is x equals 0. If I put 0 in place of x, 4 minus 0 is 4. My lower boundary is now 4. I'm going to label it u for the moment because it's new, but we won't usually do that. The upper boundary is 2. If I put 2 in place of x, 2 squared is 4, 4 minus 4 is 0. So now we have a 4. Nope, we have a 0 up here on the top. Now, the 0's on top, the 4's on the bottom, that's okay. Just as a reminder, there is a rule out there that says you can flip those to put the 4 on the top and the 0 on the bottom where it should be. And when you do that, it changes the sign. So instead of being a negative 1/2, it would now be positive 1/2 square root of u du. I guess I'll finish this one in blue. I know that this is really u to the 1/2. The antiderivative would be 3/2 as my new exponent divided by 3/2, so that's multiplying by 2/3 between 0 and 4. So here's the cool thing. I can finish the problem in u. People are going to make mistakes here. It happens. It happens every year. People are going to make mistakes. Make sure that with a definite integral, you either finish the problem in u or you finish the problem in x. I'll show you what happens in a minute, just because it always does. I can actually divide 2 by 2 right now. So this is 1/3. 4 to the 3/2. The 1/3's in front of everything. Minus 0 to the 3/2. Square root of 4 is 2. 2 cubed is 8. So this is 8/3. Okay. Now, you can absolutely finish the problem the way that it was written initially. You can put the 4 on the bottom and the 0 on the top. It will work out. You will get the correct answer. You don't have to flip it over. That's completely fine. But here's what you don't want to do. I'm going to make it red. Don't do this. A few of us are going to do this. I'm going to say don't do this, but it's going to happen. So you're going to get through all of this. And here's what's going to happen. You have 0 and 4 for your boundaries. You're going to be like, oh, wait, Mrs. Charnley said I can't finish it in u, so I'm going to put it back in terms of x. Cool. This is the where's my antiderivative? Hold on. Negative 1/2. Lost my train of thought. Negative 1/2. 2/3 u to the 3/2 between 4 and 0. This is what you're going to tell me. And then you're going to be like, oh, wait, there's a u in there. I have to get rid of that and put the x in. So you're going to do a really good job and tell me that it's 4 minus x squared. So you're going to have negative 1/2, 2 over 3, 4 minus x squared, 3 over 2 between 4 and 0. Okay. Then what you're going to do, someone's going to do 2/3. You're going to tell me this is 4 minus 0 to the 3/2. Minus 2/3, 4 minus 4 squared to the 3/2, and close the parenthesis. So here's where the issue lies. You substituted twice. So if I use colors, let's use x values are yellow. you're telling me this is an X. But then what you really did was you put in U values. We said that U is 4 on the bottom and 0 on the top. Those are U's, those are U's, these are U's, these are U's. But now you've put U where an X should be. So you've used the wrong value for a given variable. So you just want to make sure that if you do put X back in, which you're actually allowed to do, there's no issue with that at all, your boundaries need to go back to being X's. They can't be 0 and 4 anymore. Go back to the original, they can be 0 and 2. Now, if you put in 0 and 2, it will work out correctly and you'll have that correct answer of 8/3. So I know I said don't do this for some years I've not shown that and it still happens. Years I show it, it still happens no matter what. So just make sure you're being smart about your boundaries. And I think that's it. So congrats on Unit 6A. This is just a reminder of what U substitution would look like. Another reminder of U substitution. Reach out with questions. Good luck, everybody.